Good morning, everybody. How are you? Today we'll talk about the first unit about limits. This chapter is introduction chapter for the whole material in calculus. Our calculus, it's a part of the big calculus. We took this in high school, grade 12. We will be taking the basic things that we need for engineering, whether in diploma or in degree. So, what tools do we need in order to make this topic easy for us? We need three basic tools. We need to know what is polynomial. The second thing, we should be able to do substitution. And the third thing that many people don't get away from it, unfortunately we need it, which is called factorization. So, a quick knowledge of each one of those. What's a polynomial? A polynomial simply, when you have a function that has degrees of x. You could have 5, that's 0 degree of x, means x power is 1, but you could have x or 3x. You could go all the way up to x squared over 3. You could go all the way up to x power 4 if you wish, whatever the coefficient. So that's called a polynomial of degree 4. It should have at most 1, 2, 3, 4, 5 terms. These are called x terms. This is called the constant term. Now, we could have simple one like we did it in math 1. All right? So we could have a linear function or a linear polynomial. We could have a cubic polynomial. We could have up to power 5, 6. This is called poly. Poly means many, nominal means whatever the power, all right? So this is basically what you need to realize that's what we have here. That's number 1. What's number 2? You could be able also, you should be able actually, if I give you a function, let's say in terms of x, or any function, not only polynomial, such as 5x squared minus 3. How can I use substitution? We already know that. If I take x equals minus 1, then I'm going to plug in, wherever there's an x, I'm going to put minus 1. Then when you simplify that, make sure it's between the bracket, negative 1 squared is 1, and 5 times 1 is a 5, minus 3, the answer is what? It's a 2. That's simply called substitution. All right? Now, step number 3. We should be able to go for factorization. When we know that factorization comes into many different levels. There are different levels of factorization. We need the basics. Something like this form, or maybe something like this form, or something at that level. So x squared. So how do we factorize each one of those? Just a quick refresh. This is, you can see, 2 perfect squares. There's a minus between them, and the formula for that is called the difference of 2 squares. So what is the square root of x? All right, x all squared, and the 4, it's 2 squared. Then the factorization of that, you open 2 brackets, and you say one of them minus 2, one is plus 2. That's called difference of 2 squares. How about that one here? Well, there's nothing you can do except you realize something. It's taking the highest common factor 3. So you open a bracket, you put an x squared minus 2. If you expand the bracket, you've got the same one on the top. Some people say, but how about if I have something like that? 3x squared minus 6x. I cannot consider it that way because none of them is a perfect square. But if I take common factor 3, there's an x as well. What's left? This divided by this is an x. 6x divided by 3x, it's a negative 2. All right? Don't forget, here, if you multiply 3 by 2 is 6, 3 times x squared, 3x squared. While here, 3x times x is a 3x squared, 3x times 2 is a 6x. How about that one? That's called a trinomial, 3 terms. We open 2 brackets and we start thinking about what we did in math 1. This time this is an x, and 6, 3 times 2. This is different size, this goes the bigger number. Bingo, you can check it out. I know the rule is different. When you see something here, it's a plus. So please, go quickly and review that from any resource you wish. Today, we'll start by talking about how do we find a limit for any polynomial or for any form that has an x. Let's start with something simple. Let's start with some kind of definition. All right? So how do we define the following? I'm going to be using your lecture notes in 1A, 1B. All right? So, suppose we're having this kind of definition. F of x, all right? And let's call f of x any kind of function. So what is the limit of x approaches a for that kind of function? So this function, it could be any sketch. Let's have a quick sketch of that. That's your function, all right? I want to find out the limit when x equals a on the x-axis. What is the answer for that on the y-axis? So, as I approach x, whether from the left or from the right, the answer for that, you keep going, keep going, keep going. You got the point here, you substitute it in that function, and the answer is going to be y. In this case, the y, I'm going to call it L. All right? That's the basic definition. So how do we say that? The limit of x as x approaches a, it doesn't matter from right or left. Then, by substituting a in that function, the answer would be approaching something called L. That's the basic definition of the limit. Some people may say, well, give me an example to see that. Okay, let's have an example. X squared minus 3x minus 2. That's the function. What is the limit when x approaches any value of x, such as a 3? So we always expect that whether an answer exists or whether an answer does not exist. And if an answer does not exist, we have to play a little game called we factorize to check, and there could be an answer, or whether we factor or not still does not exist. This is the whole concept of that unit, at your level only. So let me substitute here. X squared, when you substitute 3, is going to be 3 squared. Minus 3 times 3, and negative 2. And guess what's the answer? 9 minus 9 minus 2, they cancel, and the answer is negative 2. Lovely. So in other words, if you take this function, if you have a quick sketch of it, not perfectly right, all right? So what we're going to have? You most probably going to have something like that one. Assuming this is the function we have here, that function, okay? And when I say x approaches 3, this is the 3, for example, since this is 1, 2, 3, blah, blah, blah. I'm going to go ahead here. When I go there, then you have an answer of negative 2. So actually, when you plug in the number 3, or whatever the number, that is possibly, when you plug it in there, that you have an answer. This is the limit. Okay. Now, in this case, we have an answer that exists. Well, can we have an answer that doesn't exist? Well, let's take an example number 2. All right, gentlemen. You remember that if you really don't follow, pause, stop the video, look at it back, double check, come back again. All right? Until you see it. Take some notes. Let's take some example. Let's give a function. Let's call it, let f of x equals, doesn't have to be a polynomial, x squared minus 3x, and it's divided by x squared negative 4. This example, a bit long, but it's going to cover lots of concepts. If I were you, I'll try to be slow. At the same time, make sure that you know what's going on. Let me see if the answer exists right away or not. All right? So, let me ask my question. What is the limit? Limit is written like that, but I'm trying to make it short, L-I-M. So don't say it lim, say the limit. What is the limit of this function as x approaches, choose a number, 2? This is an arrow. How do you read this arrow? The limit of x as it approaches x equals 2. There could be an answer here. So what's the first thing? Let's substitute. 2 squared minus 3 times 2 over 2 squared minus 2. I hope the denominator is not a 0. So 2 squared 4, 4 minus 6 is a negative 2. Yes. And 2 squared, all right, 2 squared is a 4. Am I right? Let me double check something. X squared minus 2x. I made a small mistake. This has to be 2. 2x. All right? And the denominator has to be x squared minus 4. All right. Let's double check again. So I just copied the question by mistake. I'm supposed to have a 2 here. All right, gentlemen? And I made a mistake in here also by copying. This is usual mistakes. I give you this question, you copy the piece of paper, you copy it wrong. And then you say, why am I wrong? One silly mistake, thank you, is like copying a question again by mistake. So, gentlemen, what is 2 squared? Is a 4. 2 times 2, it's a 4. What is 2 squared? 4 minus 4. The worst of this question is when the denominator is a 0. We have a problem. Any number, any x, when it's divided by 0, we simply say the limit does not exist. But would that be always true? In order to find the actual thing, or to get rid of the denominator, shall we go ahead and double check something? Let's play a little game. Let's play this game in a different way. First of all, when you play that game, okay, let me put a table to show if really this thing doesn't exist. All right? So I'm going to ask you to put x in here, and let's plug in the f of x. And let's take some numbers around the 2. Something like above the 2 and below the 2. Let's take something above the 2. What kind of number you will take above the 2? You can take 3. Can I get closer? Well, you can get 2.5. Can I get closer and closer to 2? Well, I can have 2.1. May I get something much closer than, very, very close to 2? Well, how about 2.001? Go ahead, take these numbers and plug them in that function. If I take the 3 and I plug it over there, I'm going to get something like 0.60. Try it with your calculator. And if I'm going to get something like 2.5 and I substitute over there, you will have something like 0.55556. And if you get closer, like 2.1, I would probably get 0.51216. What's going on? It's coming closer and closer to 0.5. And if I take something like 2.001, I'm going to get something like 0.05125. But what happens when I come to 2? We just said it here. It doesn't exist. Oops. Oh my God. I am unhappy. But how about if I go below 2? Something like 1. Plug the 1 over there. Something is going to be maybe... I'm going to do it for you. I have a calculator. Take the 1 over there. 1 minus 2 over 1 minus 4. And minus 1 over minus 3. It's a 1/3. Which is we're going to say 0.3333, blah, blah, blah. How about if I'm so close to 2? I could go 1.5. Okay, I can go up to 1.999. Why don't I take the 1? Because I am sure I'm coming closer and closer to this. So if I'm going to take this one there, 1.999 squared minus 2 times 1.999, what do I get in the numerator? So when I'm going to substitute f of 1.999, I'm going to get in the numerator something like, wow, minus 0.001999. How about when I go to the denominator? Well, let's try it out. I'm going to substitute 1.99 squared, 1.999 squared, minus 4, and I'm going to get 0.003999. What happens when you divide those two? Let's try them again. Negative 0.001999 divided by that answer, and guess what I'm getting here? I am getting here something like 0.4998. 0.4998. And if I've taken, guess what? 1.9999, what happens? This number is coming in so close from 0.49999. So look at those two numbers. Study them carefully. You are coming so close. I made a mistake in here. I should have put 5. Why I'm not the answer? So what's happening here? This, if you come from the right of 2, let's call this to the right of 2. Look, this is the 2 on the number line on the x-axis. You can consider this as on the y-axis. What's happening here? As you are coming from bigger number, from 3, coming closer to 2, coming, 2.5 until 2.00001. What is happening here? You are the y. It was somewhere here, coming 0.6, coming so close from 0.6 on the y-axis. But as you're coming closer and closer and closer, actually you are coming closer from what? 0.49999. But if you think about it carefully, look at it here. You are coming so close from 0.5. So it was 0.6, 0.5, 0.50, 0.500, 0.5000, until you're so close from some limit. On the left-hand side, as I'm taking it from 1 as being what? Being 0.33333. As you're coming closer and closer and closer to 2, from the left-hand side, what is the answer coming closer to? Also, it's coming closer to 0.5. That, if you remember, we called it L. Remember from the basic definition? So whether you go from the left or the right, you are coming so close from one single limit that you cannot get it by direct substitution. So what is the solution for this? Before we go to solution, remember, this is any sketch of the function. I'm not going to tell you that this is the perfect sketch. But as you're coming from the right, we call this in English the limit of the function as x approaching 2 from the right. This is called plus. This means you're approaching it from the right. From there, this is called the limit of the function, that function, as x approaching 2 minus. What does it mean, 2 minus? Means from the left. So I've noticed that it's coming close from L, and I've noticed it's coming not from L. And as those two limits are exactly the same, then I can end up with a conclusion that says as the limit of the function where x approaches at 2, if you go from the right and if it was from the left, they are the same. I just proved it to you that this is going to be and this is going to be what? Not anymore ugly face, not anymore doesn't exist. It really exists. 0.5, which is in English exactly half. Some of you will say, oh my God, so the answer is simply L. Yes. But when we go to the examination material, we're not going to do all this analysis to find an answer. We're going to use a tool that you already know it. What is that tool called? Factorization. So remember, I've explained it to you by using a simple table to let you see whenever you go above the 2, to the right of the 2, coming so close and close and so close to 2, the answer which wasn't existing, now it exists. It's half. And if you come so close from 2 to from the left, from 0.5, from negative maybe 10, 100, but as you're getting closer and closer to 2, like 0.5, 1, 1.5, 1.7, 1.9, 1.99999, as I proved it to you from here, then the answer, wow, so nice that it's actually approaching the y to 0.5. I'm not going to ask you to draw a sketch. I'm not going to ask you to show me examples of those numbers above and below or right to left to get the limit, but I'm going to be asking you something much simple. How is going to be my question? My question simply is, if it doesn't exist in here, if the answer, when you divide anything by 0, look at it carefully, it doesn't matter if the answer on the top, if whatever you have on the top, 5, 1/2, 3, minus, but if the answer in the denominator comes 0, your next step is to double check by factorization. So, let me continue the answer of this question by factorizing the numerator and the denominator. And we hope something will cross out. So as I said before, any common factor between those? Yep, x. What's left? X squared divided by x is an x. 2x divided by x is a negative 2. Close the bracket. Wow. Can I factorize this? Yes, difference of 2 squares. And what is that? X minus 2 and x plus 2. And guess what? Something is crossing out. Bye-bye. So, that original function, I reduced it to this. I can also reduce it by writing a simple form. Okay? And I put in the top x and the bottom is x plus 2. So what should I do in this case? Just let me remind you what happens in section 1.4 in the second limit worksheet, that this, because division, I can go like that. The limit of x goes to 2, of x alone, because divide, I can say divide, by the limit of x plus 2 as x approaches 2. I'm trying to explain the rules that written in page, in this next section is the same thing because they're both coming together. Let's substitute. I'm going to substitute 2 in here because there's a rule says if you have an x variable here, plug the 2 over there directly, and here plug the 2 in that x plus 2, and guess what happens? You can rewrite it like that, and the answer is half. Oops! I've used all the rules that I've learned before from factorization, okay? And there are some basic rules in the limits that whenever it's divide function by a function, you can write them like that and substitute each one separately. Even if you have multiplication, you multiply them, okay? And whatever rule you want to use, in this case, go ahead and use it. So make sure you can see that in section 1.4 of the lecture notes called limits 1b. And specifically, this is in page 3. Some people must, actually all of you must put the lecture notes that you have in your LMS with this video. It will help a lot. So what have we noticed? I've done it here by using graph. I'm not going to ask you to draw a graph. I will probably give you a graph and ask you a few questions. What is the usual thing, the famous thing? You need to make sure that if I give you any function, and if you substitute, you got an answer, okay, stop. You've got your limit. But what happens when you have something over 0? You will technically say it doesn't exist. That's tip number 1. So all of this plug-in and quick thing by using calculator, you may get an answer, then you got it. But if you don't get an answer and you got something like that, where because the denominator is 0, then your second step is to factorize. And when you factorize, then substitute. Some of you may say, but sir, do I have to do that? I only explain the basics, but you can go directly and say, substitute 2 divided by 2 plus 2. And 2 over 4 is a half, which is 0.5. It doesn't matter. You want to go step by step, it doesn't matter. But my advice is to realize how to. This is the core concept of this chapter. So we're now going something advanced like you've done in grade 12 in high school. Simply, when you plug in a number in any kind of function, could be a polynomial, could be a fractional, could be any kind of function, you got 2 possible answers, 2 possible ways. When you substitute and you got a 0 in the denominator, you have to continue and factorize and plug again, and you got an answer. That's called L. This is your lovely L. You can leave it exact or you can leave it like that. It's exact anyway. But if you got, for example, this over 3, like let's say you substitute blah, 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 regardless whatever this limit, which is called A, you may get 5 over 7. Stop it, 5 over 7. Or you may get 1 or negative 2 or maybe 0. 0 is an answer. So these are called L. But in case the limit does not exist, you have to factorize, cross the things that you done in factorization, whatever left, substitute in them, and if you got an answer, this is your limit. But some people say, but suppose I get again 0 in the denominator. Well, after that, no matter what you do, you should stop. It doesn't work. All right, gentlemen? Okay, so in this case, we talked about a great example. This example, you will see lots like that in the second lecture note in your LMS, and in your third lecture note. Actually, it's an exercise lecture note. It's called, we have 3 lecture notes. Limits 1a, limits 1b, and the third one, limits 1c. In 1c, it's all practice. Questions. Solve as much as you want. You have a problem? Call me. I can help you. Even if you have a quiz or an assignment, it's better to talk to me rather than just waste your time and ask your friend. I'm your friend. I will stay with you for 6 weeks directly. Like they say, 7/24. Those 2, explanation of the facts, of the theory, and there are some examples. So what I did so far, doing some from here, something from here, because they come together. All right? Okay, now let's do some example. Let me show you example 3. What else you expect to understand? I'm going to give you a sketch, straight line, all right? And from here, I am going to go, this is a point, this is empty from here, all right? All the way until somewhere here. This is the function. This function consists two lines. This is your x-axis. That coordinate is something called 1, and this is 2. And the y-coordinates in here is called 1, and this is like 2 on the y-axis. Okay? I'm going to call all this function fx. So this function, it has two pieces. One from 0 until there. This is black, solid, exists, while this is at y2, okay, it doesn't exist at that point. And this graph starts from here. Okay, two straight lines. All right? So what's my question here? Just for your information, this straight line is a straight line that goes through 0, and from your information, it goes all the way that way, and it can go all the way up there. But I want that piece, so I can write this graph within two pieces. The first piece that goes from 0 until 2. What is the name of that graph? All right? This is, as you can see, 1, 1, half, half, 2, 2, 3, 3, minus 3, minus 3. That's simply y equals x. So instead of saying y equals x, I'm going to say f of x equals x, where all the values of x are from 0 to 2. Actually, my sketch is from 0 to 1. So I can draw the line all the way. I don't want to do that. Just want it from here to here. How about that line? Well, if you notice, this line actually comes from there. So what I did, I cut a piece. I took this piece only. So what's the equation of that line? The equation of that line, if this is 3 and the slope is minus 1, you all know the equation of the straight line, mx plus c, and the equation of the straight line, the 3 is the y-intercept, and the gradient is -1, so -1x. I can write it like minus x plus 3, or if you wish, we can write 3 minus x. I can call this y, I can call it f of x, so fx equals what? 3 minus x. All right? But I don't want it all the way behind the minus 0 and all the way above the 2. I just want it from between 1 and 2. So where x is between 1 and 2. So, ladies and gentlemen, you will not be asked to find the equation of the line. I will be giving you this function, which we're going to call it f of x, as a sketch. Or I'm going to give you now, instead of giving you the sketch, I'm going to give it to you in the form of 2 parts, or maybe 3, or maybe 4 parts. All right? So what possibly I could ask you, whether both of them. Let me ask you a question, for example, what happens in this function as the limit of x approaches x, let's say 1 from the right. And the next question is, what happens as I approach x 1 to the left? The same question will be asked there, it will going to be asked here. Let's look it up here. This is 1. This is x equals 1. I'm going to ask you what happened to the x, to the limit of the function when x approaches 1 from the right. This is from the right. I'm coming closer and closer and closer from the 1. I go up, here's 1. No, I can't help that. Okay, this is going from the right. This is the 1. Because there's something coming closer and closer to that point from the right. And what is that? It's 2. So my answer here is 2. How about if I approach that value of x for that function from the left? So I'm going closer and closer and closer. Uh-oh, there is something from the left. This answer is 1. This one, because I'm looking for L. Now, does it help us if at this point black, solid, exists, or it doesn't? It doesn't help us. So can I ask you now the next question, the final question for that? So what is the limit of x as x approaches 1 of that function? You can see those two are not equal. So the answer is simply, it doesn't exist. I can go the same discussion on that part. What is the limit of that function as x approaches 1 from the right. When you go 1 from the right, which one of these is from the right? Well, 1 to 2, that's from the right. That's to the right of 1. So I'm going to use that function. Let's substitute in here. 3 minus 1 is 2. Uh-oh. So 1 from the right is the same. How about if I ask you, what is the limit of that function in up there, that given, where x approaches 1 from the left? Like 1.9, 1.99. Why don't I take 1 itself? Which of these is to the left of 1? X is less than 1, between 0 and 1. This is to the left of 1. I look at that function. Okay? So let's substitute in here. Take the 1 and plug it in there. And you're going to have what? 1. Is 1 and 2 the same? No. So if the question comes until the end, or by the end of that, what is the limit of x approaches 1 for f of x? You would say, well, I'm sorry, these are not equal, so it doesn't exist. All right, gentlemen? So in this situation, I've talked about what we could expect in that chapter. Actually, we mixed part 1C and 1B in one section. So what are the questions that expected in that whole unit? Unit 1, limits. You could possibly have 3 different type of questions. You could have a sketch and ask a few things about it, or you could have hybrid, or let's say 2 parts, 3 parts of a question where you have to substitute, but make sure you know what is the left of 2, or what is the left of or 1, what is the right of number, and what is the left of that number. And number 3, when you have a question, you find the limit, you have to substitute, but unfortunately you will get a 0 in the denominator, it doesn't exist. Then you have to have the skill of what? How to factorize. These are the 3 skills you need. So you better watch that first, have the lecture notes next to you, read it after that, and then get involved with your instructor in the class discussion, because we're going to be using something called whiteboard discussion. In that whiteboard discussion, you've got to exist in the meeting, in the class, to see and to discuss and to learn and to ask questions. Okay? Thank you very much. Bye-bye.